Okay, so now we move to the next part, which is the implicit function for the partial derivative. Okay, so normally before this we deal with the explicit function. Okay, what is the explicit function? Explicit function is a function in which the dependent variable can be written explicitly in terms of independent variable. Maksudnya, this is dependent variable. Okay, we can write explicitly. Maksudnya, z with respect to the independent variable, which is x squared plus 3y power 5, for example. Okay, where x and y is the independent variable. Okay, we can separate it. Okay, but how about implicit function? What is implicit function? Okay, z is a function of two variables, x and y, and z is the dependent variable. X and y are independent variable, but z cannot be explicitly expressed in terms of x and y. Okay, for example, this case. So we cannot have the equation like z equal to in terms of x and y. Cannot. Why? Because z cannot separate from this equation. So because z is inside the sign here, so we cannot modify until we get the z equal to independent variable. Okay, so we call this equation as implicit function. Okay, so now how I want to define the partial derivative for this implicit function. Okay, so we have a theorem here. Okay, if the function xy, okay, and z is equal to 0, then implicitly define a differentiable function z as a function of two variables x and y. Then we have del z over del x. Okay, so which is equal to negative, yeah, negative the partial derivative for x over the partial derivative for z. And then if you want to find del z over del y is equal to the negative the partial derivative of y over the partial derivative of z. Okay, so now let's look at the example. Find del z del x and also del z del y, where z is a function in terms of two variables x and y, and implicitly defined as this one. So we need to find the f x y z equal to 0 first. Okay, before we use the formula. Okay, so x y squared plus z y plus x sine y cubed plus 2z equal to 0. Okay, so therefore this is the f x y z. Okay, now we want to find the del z over del x. So we know that it is equal to what is the theorem just now? The f x x y z over the f z x y z. Okay, and the second one is we want to find del z del y, so it will be negative f y this time. Okay, so x y z over the partial derivative for z x y z. Okay, so we will use these two formula. Okay, so now we already have f. Okay, so we want to find what is fx. Okay, so fx meaning that we will hold the y and the z as a constant. Okay, alright, so we'll have y squared plus, okay, zy constant will be 0, so x sine y cubed plus 2z, so will be plus sine y cubed plus 2z. Okay, how about fz? Fy. Okay, so we'll have 2xy plus z. Okay, plus this time this is chain rule for x sine y cubed plus 2z. Okay, so it will be x Okay, we need to differentiate sign. What is the differentiation for sign? It is cos x. Cos. Okay, so we'll have cos y cube plus 2z. Okay, so we need to multiply with 3y squared. Okay, so we rearrange, we obtain 2xy plus z plus, okay, so bring 3 in front, 3xy squared cos y cube plus 2z. Okay, so now we want to find f z. Okay, so f z is equal to, okay, so xy squared is 0, z y is y plus, okay, this time x cos y cube plus 2z, so this time we need to multiply with 2. Okay, so which is equal to y plus 2x cos y cube plus 2z. Okay, so now it's easier for us because we already have everything. We already have the fx, fy, fz, so we just use the formula. Negative fx is y squared plus sine y cube plus 2z over fz is y plus 2x cos y cube plus 2z. And del z del y is equal to negative. Fy is 2xy plus z plus 3xy squared cos y cube plus 2z over the whole thing here, y plus 2x cos y cube plus 2z. Okay, so we already solved for del z, del x, and del z.